In the math course that I teach, a student can be given two equations and asked to solve the system. In this course, the equations will be a combination of straight line and quadratic. So here we have y equals 2x, which is linear, and y equals x squared plus 1, which is quadratic, and we are being asked to solve, which means we want to know at what points of intersection does the straight line intersect the parabola. I'm going to use comparison to solve this. In this case, both of the equations have y isolated, so I'm making what y is equal to in the first equation equal to what y is equal to in the second. And that means I have 2x equals x squared plus 1. Now I can choose whether to solve this with factoring or with the quadratic formula. So I'm going to start by solving it with factoring. I'm going to make the equation equal to 0. 0 equals x squared minus 2x plus 1. Factoring, I get 0 equals x minus 1 times x minus 1. We have the same binomial appearing twice, which means that there is only one solution. Making x minus 1 equal to 0, I get x equals 1. I have the x coordinate of my point of intersection. If x equals 1, using this straight line equation, y is equal to 2 times 1, so therefore y is equal to 2. My answer in a coordinate pair is 1, 2. Now if I use the quadratic formula instead, I'm going to get the same answer, but I'll prove it. Using this version of the equation, a equals 1, b equals negative 2, c equals 1. The discriminant is equal to negative 2 squared minus 4, 1, 1, which is 4 minus 4, which is 0. And of course, a discriminant of 0 means that there is only one solution. Using the formula, negative b plus or minus the square root of the discriminant over 2a, I get negative of negative 2 plus or minus the square root of 0 over 2 times 1, which gives me 2 plus or minus 0 over 2. There is only one answer, and it is 1. My final step is going to be the same. I'm going to plug x equals 1 into one of the equations and solve for y, so I get the same answer, of course. And the reason this is happening in this way with only one answer is that if I were to graph this quadratic and this straight line, the quadratic opens upwards from a vertex that's on the y-axis. The vertex is 0, 1. The straight line has a slope of 2 and goes through the origin. So what's happening is my straight line only touches the quadratic at one point. And that point is, of course, the solution we found, 2, 1. So this is one example of solving a system of equations where one of them is quadratic and the other one is a straight line.